Hello, good morning, everyone. My name is Mohammad Hakil, and today I'll be presenting on the topic of creative laboratory experiments for basic physics using computer data collection and evaluation. And the purpose of this presentation is to demonstrate how modern computer technology, particularly the intelligent school experimental system, is being used to improve the learning experience for non-major physics students through creative hands-on laboratory experience. And I will give a brief overview of this presentation. We will begin by looking at how computers and transforming physics education. Then we will explore specific experiments conducted using the ISES system, followed by discussion of the system's unique features. Finally, I will share the overall impact this approach has on students' engagement and understanding of physics. And next, come, let's go to our presentation and let's start our presentation. And the topic for this presentation is computerized physics labs for non-major undergraduate students. And in this presentation, we have 5 contents. The first one is introduction, and the second one is ISES overview. The third, the role of computers in physics education. And the fourth one is other experiment. And the last and least is conclusion. Yes, let's go to the introduction. The overview of the ISE's Intelligent School Experimental System is a modular, computer-based system designed to make physics experiments more interactive and data-driven. And the next point is it integrates hardware, sensors, experimental modules with software for real-time data collections, analysis, and reporting. And next is particularly suited for non-major physics students who benefit from practical hands-on learning rather than theory-heavy instruction. And the aim of this presentation and aim of this paper is to modernize the teaching of basic physics by using computer technology to make experiments more intuitive and engaging for students, particularly those not majoring in physics. That means the students who are not doing physics, but they can learn the physics without without knowing the theory, something like that. And what is the role of the computers in physics education? The first one is traditional physics teaching is often too theoretical. Most undergraduate students encounter abstract concepts and idealized systems that don't resemble real-world applications. This can result in students disengaging or developing a limited understanding of relevance of physics in the modern world. And the second point, the second role of the computers in physics education, the computers help bring real-world phenomena into labs. Computers allow real-time data collection and simulation, making experiments more accessible and relatable. They enable students to see immediate results and understand physical phenomena through hands-on experience. And the third role of the computers is integrates instructions, data collection, and evaluation. The system combines interactive web-based instructions, real-time data acquisition, and automated analysis. Students can conduct experiments, collect and process data, and compare results all in one place. And for example of the experiments using ISES is optics, diffraction, and quantum physics. Students measure the diffraction patterns of current light, example laser passing through a slide. They explore the Heisenberg uncertainty principle by evaluating how the position and the momentum of quantums can be simultaneously determined with infinite precision. And the next is magnetic field mapping using Helmholtz coils. Students can map the spatial distribution of the magnetic field around Helmholtz coils. The experiment used Faraday's laws of induction and electromotive forces measured to create a vector representation of the magnetic field. Thermodynamics, real gas compression. Students observe how real gases behave when compressed quickly, simulating adiabatic process. The system records changes in pressure, volume, and temperature in real time, and students analyze the resulting data. And if the features of ISES, open module system, real-time data processing, and interactive control, supports creativity in experimental design. For example, if you take module system, ISES allows instructors and students to customize experiments by adding different modules such as voltage sensors, temperature detectors, and light sensors. This flexibility makes it adaptable to a wide variety of physics experiments. And secondly, for real-time data processing, data is collected and processed in real time, allowing students to immediately see the results of their fractions. They encourages experimentation and interactive learning as students can adjust the parameters of their experiments and observe the effects. And for third one, you can take support creativity in experimental design. The open nature of the system encourages students to be creative in how they design and conduct experiments. They can choose different configurations, sensors, and setups to explore various phenomena. And the last, simultaneous data collection on multiple channels. ISES can collect data from multiple sensors at the same time, making it possible to analyze complex phenomena with many variables. It simplifies the experimental process by integrating data from multiple channels into one cohesive analysis. And the last, the conclusion and impact on education. For conclusion, I have done take 2 points. Enhances students' understanding of physics by linking theory with practice. By using ISES, students can apply theoretical concepts to real-world problems, seeing firsthand how physics principles work in practice. And encourages creativity and hands-on learning. The interactive nature of ISES allows students to explore and discover concepts on their own, fostering deeper understanding and engagement. Students learn to think critically about data, experiment design, and scientific reasoning. And the last, increases engagement and comprehension for non-major students. Non-major students who are not doing physics, why not? Have a strong foundation in physics? Find the hands-on approach more interactive and engaging. The ability to visualize data and phenomena helps students grasp complex concepts and stay interested in the material. And thank you for the presentation and for the audience who are listening to my presentation.